Okay, so next let us discuss the velocity and acceleration vectors. You know how can you write the velocity? If you have displacement defined like this, if the vector r that represents the position vector of a moving particle p. So in that case, the velocity, and if this t represents the scalar time, right? So it does not have any direction. In that case, the velocity is defined to be the vector by the vector v, which is equal to the first derivative of position vector with respect to time. So this is the velocity. And what is acceleration? Acceleration is defined by the symbol a. This is either you take the first derivative for this velocity vector, or you take the second derivative of this velocity with respect to the vector t, with respect to the scalar t. So this represents the acceleration of the given particle, right? So let me give you one question. The question says, so we have this question: find the magnitude of velocity and acceleration of a particle which moves along the curve x is equal to 2 sine 3t, y is equal to 2 cos 3t, z is equal to 8t at any time t is equal to 0. So here we have to, this is the position. First of all, we have to construct the position vector. So what if this r represents the position vector, so you could define this to be equal to this xi cap plus yj cap plus zk cap. Now you are given the values of x, that is 2 sine 3t. So this becomes I cap, then you have 2 cos 3t j cap, and then you have 8t k cap. This defines your position vector. Now the next thing is you are to calculate the velocity. So your velocity v dash, that is going to be equal to the first derivative for this position vector. So when you differentiate it with respect to t, you will obtain 6 cos 3t, I cap would come as such, and then the derivative of this quantity would be minus 6 sine 3t j cap, and then its derivative would be plus 8 k cap. So this is the velocity, and its magnitude could be simply calculated by taking the square root of the square of the component. So you have 6 cos 3t whole square plus minus 6 sine 3t whole square plus 8 whole square. So finally it comes out to be equal to 10. You can solve this and verify this yourself. Next we have to calculate this acceleration. So what is this acceleration? This is either defined to be the double derivative for this r vector, or this is defined to be equal to the first derivative for this velocity vector. Now you have this velocity vector, you just have to take its first derivative. So it comes out to be 18, or actually minus 18 cos 3t I cap, and then minus 18 cos here it would be sine, right? Yes, minus 18 sine 3t I cap, and then minus 18 cos 3t j cap, and then 0 k cap. So this is the acceleration, and what is the magnitude of this acceleration? That is simply equal to square root of minus 18 sine 3t whole square plus minus 18 cos 3t whole square. So this comes out to be equal to 18. So this is your answer. Okay, so let us now see next question related to this topic. So the next question here is, you are given that a particle moves along the curve x is equal to t cube plus 1, y is equal to t square, and z is equal to 2t plus 3, where this t is the time, right? Then you are asked to find the components of the velocity and acceleration at time t is equal to 1 in the direction of I cap plus j cap plus 3k cap. So this is what you are asked here. So for the solution, we'll first calculate what is the components of velocity and acceleration at the point t is equal to 1, and then we will evaluate those components along this particular direction. Okay, so for that, firstly, if this vector r represents, let r represent the position vector, then what is the component of the vector r? Then r vector is defined like this x I cap plus y j cap plus z k cap, right? So this is equal to, because in the question we are given the value of x as this quantity t cube plus 1, so we have t cube plus 1 I cap, then t square j cap, then 2t plus 3 k cap. We are given this quantity. So what we have to do, you have to calculate the velocity vector. So that is equal to the first derivative for this position vector. So that is 3t square I cap plus 2t j cap plus 2k cap. So this is the velocity vector, and then what is the acceleration corresponding to this? The acceleration would be the derivative for this velocity vector. So that means we have to take the derivative of this vector. So that would be equal to 6t I cap plus 2 j cap plus 0 k cap. So this is our acceleration vector. So now we have to evaluate the value of acceleration as well as velocity at the point t is equal to 1. So at t is equal to 1, your vector v, that is going to be equal to, instead of t you will substitute 1 here. So you will have 3 I cap plus 2 j cap plus 2 k cap, right? And acceleration, that would be equal to 6 I cap plus 2 j cap at the point t is equal to 1. So now you have the vector for velocity and the vector for acceleration. The next task in the question is to evaluate the components of velocity vector and the acceleration in the direction of this particular vector. Now, first of all, you have to determine what is the direction of this particular vector. So that means, so we have to determine what is the direction of the given vector, which is given to be I cap plus j cap plus 3 k cap. Now the direction of this given vector is calculating the unit vector in the direction of this vector. So the unit vector here would be the vector itself divided by its magnitudes. And what is the magnitude? Square root of 1 square plus 1 square plus 3 square. So that is equal to I cap plus j cap plus 3k cap divided by 1 plus 1 plus 9, that is 11. So square root of 11. So this is the unit vector in the direction of I cap plus j cap plus 3k cap. Now we are to determine the components of velocity in this particular direction, right? In this particular direction. So we will say the component of velocity along the direction I cap plus j cap plus k cap, this is going to be the velocity vector dot product with this particular direction, the unit vector in the direction of this vector. So that is I cap plus j cap plus 3 cap divided by square root 11. And what was our velocity vector? It was equal to 3i cap plus 2j cap plus 2k cap. So we have 3i cap plus 2j cap plus 2k cap. So when you compute this, it comes out to be 3 into 1, that is 3, plus 2 into 1, that is 2, plus 3 into 2, that is equal to 6, divided by square root 11. So this is equal to square root 11. So this is the component of velocity in the direction of the given vector. Next we will compute the component of velocity along the vector I cap plus j cap plus k cap. So this would be equal to the vector of acceleration into this particular direction, I cap plus j cap plus 3k cap divided by square root of 11. So let us see what is our acceleration vector. This is 6i cap plus 2j cap. So we have 6i cap plus 2j cap here. So when you compute this dot product, 6 into 1, that comes out to be 6, 2 into 1, that comes out to be 2, and plus 0 into 3 comes out to be 0, divided by square root 11. So this comes out to be 8 divided by square root 11. So this is the component of acceleration in the direction of the given vector I cap plus j cap plus k cap. So I hope this is clear to you all. Well, that is it for this video. Thank you for